Hello, my name is Sven Köppel and today I will show how to obtain, install, compile and run an exahype example application. Exahype is an exabolic hyperbolic PDE engine and you can find it in the internet if you just search for a name. For instance, exahype U is the website of the Exahype project. To run the system on Linux, you see here I just have a Fedora system, a very basic system. You only need basic tools like GCC to compile, Java to execute, but we will see very soon. So currently you will get a build at GitHub where we will soon release code. It's not there up to now, so anyway you can go to GitLab, which is the internal site we use currently, and then we have the project's closed source here. You see it's a pretty huge repository, 600 megabyte, and we don't download it in this movie. This movie will only be around 10 minutes. There's a small guide how to run this, and we will just closely follow. So instead of running git here to clone this from the website, I prepared something to speed things up. So make sure you run the video in high resolution, otherwise you will probably cannot see all the details. So I set up an empty directory where I will work, and then I just run a clone command, and instead of using the address given here, we clone from local hard disk drives for showing how it works. So this is the repository, 600 megabyte, and you can see it's even bigger, it's 1 gigabyte of files here. Let's explore what we got. We got this code directory, other files which we are not that interested in the moment. You can, I think you can also have a look into the guidebook. Okay, it's not compiled here. We do the following. As you see here, first we have to update Piano. Piano is an external dependency on exahype, and it's not shipped by default. It is supposed to be in this directory, and here we have the tarball. So what we do is we go there and we extract the tarball, just like it's written here in this command. Okay, so it's done. We got Piano. We have Piano here in several directories, all nice. You can skip this command, and now there's something we call the toolkit, which is a jar file basically, and this toolkit will be used to generate code, which currently resides in these execution examples. Actually, we can also look into this directory here in graphically. So you see we have plenty of applications right now. And every application contains some PDEs which are linked or in some specific way together with solvers like ADG solvers or finite volume schemes to solve these PDEs in the Exahype framework. And today I will emphasize on kind of hybrid applications which have Fortran code inside, because everything in Exahype is C++. So let's go with the MHD. When I talk about MHD, I mean resistive MHD, which is solved here. You can look here just into the PDEs to see what's going on. You have the eigenvalues, 9 eigenvalues, no, 2 eigenvalues. So it's again, not the exact eigenvalues, but you see 9 quantities filled out. You have fluxes and sources, and for source we here have the diff cleaning approach. We can just explore what's inside. As you see here, there are parameters there. We have set the diff cleaning to some value. However, what we do now is to generate code which is missing here. So this is something. It's not it has to be regenerated by the toolkit, and to do so we use Java. So you should make sure you have a decent Java version, and then we can just use the toolkit exahype.jar and run it with an argument, and the argument is the specification file of this application, of the MHD application, and this is, I always try to keep the names of the applications similar to these spec files. Spec files have .exahype at the end. So you have seen here mhd.exahype, and this is a specification file. We have paths here which describe where the code will go. We have runtime variables, and interesting for us is that we have here saying that it's C, but in the end it's function. Okay, so we pass this file as an argument, and currently, so we have application examples and mhd.exahype. This is exactly this file, and I just run this, and it goes and does something and asks me to press enter several times, and then I just do my resize of Windows, so it's probably easier to see. Okay, full screen, and I press enter, and I press enter, and it does something, and so on, and okay. So after all, something is generated, even more, and we can see to application examples mhd now that we have a much more CPP file than before, and there should, well, it's actually the code. Something went wrong. That's a good thing that something went wrong. I mean, I'm looking for the make file. Oh, it is. No, it is there. Okay, nothing went wrong. Ha, nice. Let's have a look into the files. Okay, so this make file wasn't there before. It was just generated. We have here paths on my computer. Don't ask me why it uses that, but it's okay. This is currently configured as using all these thread building blocks and parallel stuff. We don't want it in the moment, so let's disable it by just typing it on here. This is something we have to ensure. The toolkit doesn't do everything we want. And okay, now the toolkit also asked us to set environmental variables. We just scroll up the toolkit and set it here. So to know what kind of compiler we use, we have to set these variables, environment variables. We also set here the mode. Let's say release. We don't want assertions. Then we also have here this, I don't know, this crazy stuff here. That's something people put there. And we have a distributed memory, and we just set it to none. So you see, we always have here a set of 4 variables which we have to keep track of. And now we can actually start making stuff. And this will take some time. I have here a computer with 4 cores, so okay, anyway, let's say 6, and typically takes 5-6 minutes. Okay, what we see here is typically for a Fortran application, so there's a dependency on Fortran modules which are not built because the build system is not tracking them correctly. We just call make again, and then it works. And during all this, if you see, I want to introduce some fancy thing, some fancy tool which simplifies life a lot. And it's in the misc directory here, and it's in build scripts, and it's called exa. And let's see what exa does. So it's a script which allows a lot of different commands, and all that they just do other stuff. You see, I mean, for instance, running the toolkit, compiling the toolkit. No, this is running the toolkit, compiling something, compiling for different orders or whatever, and so on. Interesting. It is interesting for compiling because I've written this kind of wrapper script here to compile stuff. Let's have a look into this. It's here, right? You see compile.sh, and I will also open it here with the it's a number of all these variables we have to keep track. It sets for us, and it cleans for us stuff, and it runs a toolkit before, and it makes workarounds if code was auto-generated and we didn't make the git, which you actually didn't. So it's already made one mistake, which this script would not have made, and it calls make. So I personally prefer to run stuff with exa. Funny thing with exa is that you can put it to your path, so you can run it forever. You just type exa. You don't. You can go anywhere and type exa, and it knows where you are, so you don't have to change the directories all the time. And you can compile stuff from any directory. You don't have to take care where you are. Fun thing is that exa detects where it is in the beginning here, where it's installed. So there's another exa, then because I have several installations of exahype on this computer, so okay. If you want to install it, then just, take some binary directory like bin or user bin, or maybe you want to take in your home directory the directory bin, and there you see I have this just a symlink to the exahype to the script, which is very practical for me. Okay, so it was compiled. We could, by the way, I could have just written compile mhd and have made it the same. Okay, but anyway, so what we got now from the compilation is this binary, and if you look at the size, it's quite large, 5 MB, okay. And we can start it, and it wants the specification as a parameter, so we have to give it the specification file as a parameter again. And now it says, okay, there's one of these special fancy writers I introduced, which reduce fields to scalar values, so we have to create directories for them just because the whole thing is not that cool already. And it runs. It's running and running, and this is the desired output, which is quite nice. Actually, I don't know how long this one runs. Maybe we can have a look. Can we? Do we have the other files open anywhere? We can have PE. Let's see if we have them. MHD exahype. So okay, this time it's running very long. I mean, this is we currently have in the MHD an wave test case. So I will open it so you can see what where. As you see, it's creating tons of files, which is horrible. So it's very difficult to find something anymore here. Maybe it's possible if we do it like this. Initial, I see, it's crazy stuff here. Initial data. It's actually impossible to do anything more if you do everything in one directory. Initial data stuff. And if you open the Fortran file, then you see there's here the wave currently set, and the wave here is defined. It's an exit solution, so we know it for any time t, but we impose it only for the initial time and then use it to check correctness of exahype, and here you see the definition. So actually it's a test which is follows closely the papers you can see by Olin Zanotti and Michael Dumser. I'm not sure in which paper it directly is, but you see these tests, you just look up one of these papers. Maybe it's the test is also here in this one, and I think it's well, they have other tests here, but okay, that's a test, right? MHD wave, and they have it's exactly the same equations here, so you find that it's quite popular. We can look at the output here if you want. So there are so many files now, and you can open these files with ParaView. ParaView, if you it's an open source program, you can just install it. And okay, where is it? It's here. Nice. We have to go to the directory, which means okay, this is not the demonstrations where I am. Okay, so applications, examples, MHD. And you see the fields. So let's look at the conserved values, which are the ones. So we have the specific plotter type here. We can look at the first value of the B field, and there you are. And we look at it, and well, it looks nice. And now we get crazy wrong values here. But this is a story, right? I mean, this is the current state. Okay. So I mean, what you would expect a sine wave forever, right? I mean, it's exactly the solution. Okay, this was an application using Fortran for the case of the application definition of the PDE, and it was linked to the main file in code in this one here, where you see that you have basically C++ functions which invoke Fortran functions, and that's the whole deal. There actually is still something different, so we can also use the ADA scheme, which is used here, written in Fortran, and also the from in Fortran. Maybe it's something for another video, but actually I wanted to demonstrate how to compile this. Fun thing is, it's exactly the same. So I mean, let's do it with the exa tool, right? I mean, I like the exa tool. Oh, yeah. Okay. I mean, let's remove my thing, my exa I have, and install it again, and nicely again. Okay. So we copy the path to exahype, and let's quickly view if we can find the build script. Yeah, there it is. So what we do to install it is to go to our directory with binaries we have, and link the exa file, move it to remove the appendix, and then we can use it from everywhere. So you see, we can exa is very nice. It allows us, for instance, to unpack the piano thing from anywhere just by invoking this. And for instance, it allows to recompile the toolkit just by invoking this. Okay, it doesn't work because I don't have it fully deployed in Java here. But okay, do I have a Java compiler? No, I have a Java compiler. Okay, so we can, for instance, run the toolkit now on exahype-dev just to. I mean, you have to type it correctly, right? If you can't spell English. Okay. For instance, it made all the enters for us, so everything is done very easy, very thin. Let's do a make clean just to be sure. It's always a good idea to make a make clean, and then we can also what did I just do? Oh yeah, great. Exa compile exahype-dev, which is what we want to do. Try make compile. I mean, okay. So yeah, it goes on and compile stuff. We don't have to care about environment variables. It's just for us. I mean, we don't need TBB, we don't need MPI. Exahype for us is not about high performance, it's just about getting something solved, getting right math done right. Yeah, so it takes some time. Is there something else I wanted to display? I mean, you see, we solve exactly the same equations in very different ways. Not very different, I mean, programmatically different ways. So we have in different programming, we even have a CPP version here. Oh, nice, isn't it? But nothing works. It's funny. And so it compiles currently. It demands all these files. By the way, I think there's something. Oh, that's also what the toolkit did for us, is checking that here in this stuff. This is important. If you don't need use this exa tool, then you get into hell, because you have to make sure that that this file here was in the Git repository, and you have to get it updated, because this was overwritten by the toolkit, and if you don't get this out of the Git repository, you will not be able to compile the correct. So this is really something. This is crazy. This is too many border cases to tell something, but I mean, maybe we can open another terminal to see the difference here. I mean, you can use git to see what's in the current directory. You can use git ls files to see what's in the current directory. And you see in git that there are plenty files. Oh, I'm telling the wrong stuff, right? It's not inside the Git repository. Oh, I was wrong. Okay. Well, that means people have updated the toolkit. Toolkit is doing the right stuff again. Because it used to be that the toolkit did not generate the right code, and you had to keep track of everything. But yeah, I mean, it's nice, you see. Git is great. Exahype people are doing good work. Okay, so it was compiled. It's there. What's the side of this guy? Is it against null? Because with all versions, exahype-dev. Don't forget to run the run spec file. Don't forget to make an output directory before running. And yeah, amazing. It's working. You can also use Visit to open files, but I think it's not working that well like ParaView. Okay, that's all I wanted to say. So that's how you can use exahype. Bye from my side, and see you again.